Hi everybody. I wanted to make a video on how to factor using the differences of squares. So I picked two questions from your homework paper. So one is question 13, and I have it here. It's 45q cubed minus 20q. It's kind of a mouthful. And we need to see if we can factor this using the difference of squares. But when I look at it, I don't see two square numbers. But what have I always said? The very first thing that you do when you're looking to factor a polynomial is you want to look for your greatest common factor. Well, our greatest common factor looks like it's going to be 5q. We can factor out a 5 and a q from both of those terms. So if we do that, we have 5q times factoring out a 5q out of 45q cubed is 9q squared minus 20q divided by 5q is just 4. So now I have a difference of two squares. So I leave my 5q where it is. So I'm going to write it off to the side. I've got 9q squared. We want to figure out what's the square root of that. Well, the square root of 9 is 3. And for q squared, the square root is q. You can always take your exponent and divide by 2 when you're looking for your square root. So I've got 3q is the square root of 9q squared, and then the square root of 4 is equal to 2. So I can factor 9q squared minus 4 into 3q plus 2 times 3q minus 2. And that is as factored as it can be. So that's 13 completely factored. All right, the next question, the next question that I want to do is number 23. With 23, we're solving. So we have question 23 says 27h cubed minus 48h is equal to 0. Whenever you see an equal sign, that's usually a pretty good hint that you're going to be solving and not just factoring. But to solve, the first thing we have to do is we have to factor. So if I'm looking at these, I don't see two squares yet, but I do want to look at my greatest common factor. And I see that they both have factors of 3h. So our greatest common factor is 3h. And when we factor that out, 27h cubed with 3h factored out leaves us with just 9h squared minus 48h divided by 3h is 16. 0. Okay, so now I do have a difference of squares, and I want to factor that. So if I look over here, I'm going to write out square root of 9h squared is equal to 3h, and the square root of 16 is equal to 4. And that tells us that we can factor 9h squared minus 16 into 3h plus 4 times 3h minus 4. It's still set equal to 0. So I completely factored this, and I think this was probably the hardest one to factor. No, I don't think it's the hardest one to factor. I take that back. I think it's the hardest one to solve, because we want to take each factor and set it equal to 0. And it's kind of easy to overlook that 3h is a factor. So we're going to set 3h equal to 0. 3h plus 4 equal to 0. And 3h minus 4 is equal to 0. And we're going to solve for h on all three of those equations. So over here, if I want to solve for h with 3h equals 0, I'm going to divide by 3 on both sides, and I get h is equal to 0. So that's one solution. Now in my middle equation here, I've got 3h plus 4 equals 0. If I want to solve for h, I need to subtract 4 from both sides, and I get 3h equals negative 4. And then I want to divide by 3 to get h alone, and I get h is equal to negative 4/3. And then for my last one, it's a lot like the other one, except this time I'm adding 4. So I get 3h equals positive 4. And then if I divide by 3, I get h is equal to positive 4/3. So my answers are h is equal to negative 4/3, 0, and positive 4/3. And if I go up and look at the original equation here, 27h cubed minus 48h, I can kind of double check that, look at my biggest exponent to see it's cubed. So I have a third degree polynomial here, which tells me that I can have up to 3 answers, and that's what I have. So if you guys have any more questions, of course, you can always email me or ask in class tomorrow.